So, ladies and gentlemen, let's take an example of a full wave rectified voltage. We are still looking at the average value of a function. So now, if we divide the first half cycle into 6 sub-intervals, then we are going to have each sub-interval at 30 degrees. So now, if we want to use the mid-ordinate rule, we are going to say if I divide 30 divided by 2, I will have 15. Then here I will have 45. Here I'll have 75 degrees. Here I'll have 105 degrees. And here I will have 135 degrees. Then here I will have 165 degrees. So meaning I can put my values in a table so that I have the mid-ordinate. And the mid-ordinate here, I'm talking about 15 degrees, 45 degrees, I have 75 degrees, I have 105 degrees, and 135 degrees, 165 degrees. And what is the value? Okay, what is the value or the height of the mid-ordinate? So the value of the mid-ordinate, remember, this is defined by a function. This is defined by a function 10 sine omega t, or 10 the same as 10 sine theta. So the same as 10 sine theta, that is what this signal represents. So that means if theta is 15 degrees, what would be the value? So I will have 10 sine 15, and this is giving me 2.588 to 3 decimal places. So this is going to be 10 sine 45 degrees, and this is going to give me 7.071. Remember, this is in volts. Then 10 sine 75 degrees. This gives us what is 9.659 volts. Again, if I take 10 sine 105 degrees, I'll have 9.659 volts. Then if I take 10 sine 135 degrees, I'll have 7.071 volts. If I take 10 sine 165 degrees, I have 2.588 volts. So these are the mid-ordinates. So that means area under curve according to the mid-ordinate rule is equal to h into y1 plus y2 plus y3 plus y4 plus y5 plus y6, because there are 6 sub-intervals. And h is 30 degrees, and therefore must be put into we must put it into what? We must put it into radians. So if you sum this, let us first get the sum of these values, and we'll see. So what I have here already evaluated is going to be the sum of the whole of these ordinates. So what I'm going to do, I'll have my 2.588 times 2, because there are 2 here, this and that, plus the 7.071 times 2, because they are also 2, plus the 9.659 times 2. So when I evaluate that, I get 38.63. Okay, so this is giving me that area is giving us the sum of the ordinate. So this is giving us the sum of ordinates. So the sum of ordinates will that is the sum of mid-ordinate. Sum of mid-ordinate. Sum of mid-ordinates. This is giving us 38.636. And what we are having here, okay, what we are having here, it is going to be, obviously this is going to be in volts, okay, either degrees or radians. But remember here, what we used here, we used the degrees. But obviously sine of 45 degrees can always give you something that is like in radians, and therefore this can give you volts radians. Okay, can give you volts radians. Then later on you need to divide it by the length. So if you are to get the average value of the voltage will be sum of the mid-ordinates divided by the number of mid-ordinates. As we earlier on established, this gives us 38.636 divided by the number of mid-ordinates, and the number of mid-ordinates is 6, and this gives us 6.439 volt. So that is the average value of volt as required above. But then if we needed also, what we could do, having evaluated those values, okay, we could multiply them. We could use the mid-ordinate rule. We multiply them obviously by the value of h, of which h here is going to be in radians. Okay, so what we can do is get 180 degrees. So length over the base is equal to 180 degrees. And so what is this in terms of radians? So we know this is the same as pi. This is the same as pi radians. Okay, so now the same as pi radians. But then what is the width of each sub-interval? We said the width of each sub-interval is 30 degrees, which is the same as 30 pi out of 180 radians. And this gives us pi out of 6 radians. So if we determine area, if we use area equal to the formula that we already wrote above there, okay, will be h into y1 up to y6. So area, okay, plus, then plus. So area will be h, which will be pi out of 6 into, we sum the whole of that, which gave us 38.636. Okay, so this is pi out of 6 we can just write it as 38.636 divided by 6 pi. Then what is the average value? The average value will therefore equal to, will equal to area divided by length of the base. So the average value of voltage will therefore equal to area, which is 38.636 divided by 6 times pi, then divide by pi. So obviously this will go away and will remain with 6.439 volts as required. So this is an approximate value, but for full wave rectified voltage, we know that the average value is equal to Vm 2 Vm divided by pi. So this is the same as 0.637 times Vm. But according to our signal, which is 50, no, it is 10, our signal is 10, is equal to 10 sine omega t. That means the Vm, or the amplitude, or what we can call the peak voltage, is equal to 10 volts, meaning that our average value will always equal to 0.637 times 10, which gives us 6.37 volts. So if maybe one wanted you to get an error, then you do get the true value 6.37 minus the approximate value 6.439, because obviously these signals are the same, but because of the errors in approximating the area, we find that the true value is somewhat different from the calculated value. So those errors can be calculated. Get the error divided by the true value multiplied by 100, and then you'll be able to get the percentage error. We are saying 6.37 minus 6.39 divided by 6.37 multiplied by 100. That is if the error in that has been asked for. 6.37 minus 6.439 divided by 6.37 times 100. So we have approximately 1.1% error and negative.